Welcome back to another episode of Math with Son. Hopefully you're continuing the previous video and figuring out how are we going to deal with this y to the 1/6 power. So if it's a square root problem or something like that, you would deal with it by multiplying it by itself. But that would not help here because if you multiplied by y to the 1/6 and y to the 1/6, you wouldn't get rid of the fraction on the bottom. So when you have a problem like this, which I'm going to rewrite, we got 2x to the first power cube root of x, y to the 1/6. Top part's fine. It's the bottom part's the mess. How many more y's do I need on the bottom of the fraction so that this would end up being a normal y? Well, if I have y to the 1/6 power, I would need to multiply by 5 more of them to be able to get rid of it off of the bottom and become a y to the 6/6. So if we do that, we get y to the 6/6, which is just a normal number, y to the first power. And on the top of the fraction, we end up with 2x to the first cube root of x times y to the 5/6. And now we have equivalently rationalized the denominator and got rid of that radical on the bottom of the fraction. Now you can keep it as 6/6 if you want to be a weirdo, but 6 divided by 6 is just 1, so that's going to fizzle away and just not exist. It's just going to be a y on the bottom of the fraction. Okay? I got another example for you that's probably a little bit easier. Let's see how this one goes. So let's say I had, we'll go with 3x on the top of the fraction, and then we'll have an x to the 5/4 on the bottom. Okay? So here we have x to the 5/4. And x to the 5/4 is a rational, it's a rational denominator. I can't talk. It is a fraction to exponent, which means it's a square root. If we were to try and simplify this, we would have to understand that 5/4 is bigger than 1. Okay? And if we know that, we should be subtracting our exponents, and if we did that, we would end up with 3 over x to the 1/4 power, because if you took 5/4 and subtracted 1, you'd get 1/4. Okay? So these two things are equal. Again, we can't keep a radical or a fraction to exponent on the bottom of the fraction. So you have to ask yourself, if I have 1/4, how many more do I need? Well, I would need 3 more. So I would multiply by x to the 3/4 and x to the 3/4, leaving me with 3x to the 3/4 over x to the 4/4, which is x to the first power. And that would be our final answer on that one. Now, we could have dealt with the x to the 5/4 from the beginning, which I'm going to do on the next example. So you always multiply by what you are missing to get you up to that next whole number value. All right? So let's say that I had x to the 5/4 on the bottom of the fraction, just like last time, but instead of having an x on the top, I just have a 3. Well, now I'm not going to be able to subtract them, and I'm going to have to deal with this 5/4. So in order to deal with the 5/4, I can't really multiply by x to the negative 1/4. That really would not be probably a good move to do. But what you can do is recognize that if I have 5/4, I want to get the top of the fraction to a number that would be able to divide by 4. And if I want to get it to divide by 4, the next biggest number would be an 8 because we're already past the first 4. So if I get 3 more, I'd be able to get to 8. So if I multiplied by 3/4 and 3/4, just like we did last time, but it's going to produce a different result. It is going to produce 3x to the 3/4. And here we'd have 5/4, 3/4. If we add those together, we end up with 8/4. And 8/4 is just x squared. 3x to the 3/4, which presents a different dilemma. And it is a dilemma you do not want to solve. If you were to find the difference between x to the 3/4 and x squared, you would end up with 5/4. and you would end up right back where you began. So from this point, you don't want to find the difference between them because it will not end up in your favor. All of the x's would cancel off the top, and they would end up on the bottom, leaving you with, again, another fractioned exponent, which is not okay. You don't want that. Okay? So, what if, this is a long one, what if it was, instead of a fractioned exponent, but like a cube root scenario? So let's say we had the cube root of 4, x to the 2nd power, y to the 5th power. And let's put something really boring at the top, like a 6. Okay? Cube root is looking for 3 of a kind. Now, you could turn this into a fractioned exponent. You could turn this into 4 to the 1/3 power, so on and so forth, and deal with it that way. But sometimes it's easier to keep it as a radical, this cube root part. In order to get a cube root, we need to figure out, well, we need 3 of a kind. Currently, 4 is 2 2's. So we need 1 more 2 to get rid of the 4 and be clean on the outside. And right here, we have an x squared, so we need 1 more x to make it an x to the 3rd power. And if it were an x to the 3rd power, it would come out cleanly. And we have a y to the 5th. We would need 1 more y to make it come out cleanly as well, because y to the 6th power would be able to divide by 3. So we're going to multiply by the cube root of 2x to the 3rd, y to the 1st. I don't know why I wrote a 3rd power. Oh, no. We needed 1 more x. Apologies. We had a 2. We need a 1 more to make it 3. And we needed 1 more to make it 3. I apologize. I said the number 3, then I wrote the number 3 down. All right. 6 is on the outside. We're not going to really multiply it with anything here. It's going to be 6 times the cube root of 2xy. And here on the bottom of the fraction, where you'd end up with the cube root of 8, because 4 times 2 is 8. X to the 3rd power, because 1 and 2 make 3. Y to the 6th power, because 1 and 5 make 6. All of that is for naught, because you hopefully would realize that the cube root of 8 is 2. You wanted that to happen. 2 times 2 is 2. 2 times 2 times 2 makes 8. So you expected that to happen. And the cube root of x to the 3rd is x. And the cube root of y to the 6th, 3 goes into 6, is 2. We wanted all that to happen. So the bottom of the fraction is not really the cube root of 8x to the 3rd y to the 6th, but it's just a 2xy. The top of the fraction is still going to remain relatively ugly. You still got that 6, you still got that cube root of 2xy, and we do have our final answer. Okay, so this is not an easy topic. I already made a different video on what to do with square roots when they need to be FOILed out and so on and so forth. This is if there's a single term on the bottom and it's a cube root or a 4th root or things like that. How many are you missing to get that whole number? Okay? Until next time, I will see y'all later. I might be making another video on this because I know it's a hard topic. We will see. Bye.